So in the previous video, I explained the concepts of exponents, and at the end of the video, I gave you some problems to solve and said that I'll upload the solutions to them in my next video. So this video is that next video. Okay, here's how we're going to do it. Since there are two simplified problems and two solve for the unknown problems, I'm going to solve one out of the two types of problems and animate the solutions to the other two problems. So let's begin. We'll start with the first one. For this problem, you shouldn't get confused with this subtraction sign here. As I explained in the previous video, indices or exponents, as you may call it, is just a simple and shorter way of writing numbers repeatedly multiplying itself. So when we have a multiplication or division operation, we can check if we can represent it in exponential form, right? But for addition and subtraction operations, I'm sorry, but if it's not special cases like this one, for example, then for two unknown numbers with powers adding or subtracting themselves, as long as you don't know the value of the unknowns, you still leave the expression like that. Here's what I mean. Let's say we have 5 raised to power 3 plus 4 raised to power 2, for example. To solve this, we'll first get the actual value of 5 raised to power 3 and 4 raised to power 2 before adding them together to get our answer, right? But if 5 and 4 were two unknown numbers, maybe x and y, then unless additional information is given about the value of x or y, then there's no way you'll be able to simplify or get the value of x raised to power 3 plus y raised to power 2. I mean, if you can do that, then you can actually write the value of x raised to power 3 and y raised to power 2 in the comments. Let me see. So the point I'm trying to make by explaining this whole thing is that when you have a problem on exponents, and if there are addition or subtraction operations in that problem, your main focus shouldn't be on how to deal with that addition or subtraction sign. Instead, your focus should be on how to deal with the numbers that have exponents, especially the ones containing the unknowns. So from this property of exponents, we know that we can simplify 18 raised to power 2n plus 1 to 18 raised to power 2n times 18. We can do the same thing for 3 raised to power 4n plus 2. Now, since you can rearrange numbers in a multiplication operation and your answer wouldn't be affected, then we can rearrange this expression like this and do the same thing for this one too. I'm doing this because we can multiply the two numbers we know their values to get a single number. Also, from this rule of exponents, we can write 18 raised to power 2n like this, and 18 raised to power 2 is 324. We can do the same thing here as well. Now, since 324 raised to power n is here and here too, then we can factor it out. And now it becomes clear that since 324 raised to power n is present in both the numerator and denominator, then they'll simply cancel each other out, leaving behind 54 minus 108 all over 108. 54 minus 108 is minus 54. And when we divide out, we get minus 1 over 2, which is our final answer. So now let's move to the solve for the unknown problem. So for this problem, there's not much you can do here. And 4 raised to power n squared is not the same thing as 4 raised to power 2n, so we can't apply this rule here. But here we can split it like this. I'm doing this because I know that I'll have 4 raised to power n squared. And since 4 raised to power n squared is here as well, then I can factorize it out. And the numbers inside the bracket will now simplify to 5 over 4. And if we divide both sides by 5 over 4, we have that 4 raised to power n squared divided by 2 raised to power n squared plus n is equal to 1. Now, since we are having a division operation here, then it should be possible to apply this rule. But remember that the basis must be the same for it to work. And to do that, I'll just rewrite 4 raised to power n squared in its exponential form. And I can apply the rule now. Now for this part, I can rewrite 1 as 2 raised to power 0, because from this rule of indices, we know that any number raised to power 0 is 1. I chose 2 to be the base because it would make it easier for us to just compare the powers of both sides of this equation. I mean, since we want to find the value of n for which both sides of this equation are equal to each other, then we need to make sure that both the bases and powers of both sides of this equation are equal to each other. There's nothing we can do about the base, but as for the powers, we can factorize out n. We know that 0 times anything is equal to 0, right? So for this equation to equal 0, then one of these two expressions must take on the noble responsibility of being equal to 0. So it's either n becomes 0 or n plus 1 becomes 0. And that makes our values of n to be either 0 or minus 1. Now, for these two remaining problems, I said that I was going to admit their solutions, and I'm going to do that now. But before that, I just want to remind you that you need to make sure that you understand the solving steps that I'll use. Okay, so let's begin. You see, even though these questions might look as if they're challenging, they're really very, very simple and basic. So as long as you understand these rules and know when to apply them, then I think that there'll hardly be any problem on exponents that you can't solve. Anyways, that's all for today. See you in my next video. And yeah, please don't forget to like and subscribe. Merry Christmas. Bye.